Good evening, ladies and gentlemen. This is Mr. Holmes getting ready to talk to you guys about how to simplify complex fractions. What I would like to do again is to start off with the definition of a complex fraction. By definition, a complex fraction is a fraction that contains a fraction in its numerator and or denominator. This is my second video on complex fractions, simplifying complex fractions. If you have not seen my first one, I would strongly suggest that you start with that one first before looking at this video. In the example that I have for you guys today, in my numerator I have x over 6 minus x over 3, all divided by x over 5 minus 7 over 10. What I'm going to try to do is write a little smaller than normal to preserve space. Like I've stated in a previous video, that if you do not know how to add or subtract rational functions, then you might want to go and look at that first because it's kind of a prerequisite. Alright? It's necessary in order to understand simplifying complex fractions. Needless to say, I'm going to assume that you know how to do that, and we're going to take off from there. Alright? So here we go. Simplifying complex fractions. It's not as hard as it looks. Some people look at it and think it's a little hard. It's really not. All right. First step into simplifying a complex fraction is getting one solid numerator and one solid denominator in each numerator and denominator. Doesn't that sound difficult? No. Actually, I'm just joking. All you need is one solid fraction in the numerator, one solid fraction in your denominator. Then we can use the keep, change method that I introduced, or should I say that I reviewed from my previous video. Here, to get one solid fraction in my numerator, I'm going to simply multiply opposite denominator times opposite numerator over the product of the denominators themselves. In this case here, I will multiply x times 3 minus x times 6 all divided by, and I'm going to zoom in some so you can see a little bit better, the product of 6 and 3. What I'm trying to do is to show you guys that I am multiplying opposite numerator times opposite denominator every time, all over the product of the denominators themselves. Alright, here again I'm going to multiply opposite numerator times opposite denominator here, so I'm going to have x times 10 minus, because it's a minus sign, that's why I'm getting a minus sign here, 7 times 5 opposite numerator times opposite denominator, all over the product of both denominators. It's just that simple, folks. Don't make it any harder than what it has to be. Okay? So what I'm going to do now here is I'm going to actually simplify both fractions. In doing so, I'm going to multiply 3 times x here. I'm going to multiply 6 times x, and I'm going to multiply 6 times 3. 6 times 3, well, we already know this is going to be 18 as a denominator. Here, and I'm going to zoom in more so you can go look at 2 steps at a time. Here, this is going to give me 3x minus 6x when I multiply 3 times x and 6 times x. Alright. Here, I'm going to multiply 10 times x, and it's going to give me my 10x minus 7 times 5, which will give me 35, all over 5 times 10, which is simply 50. Notice now we have one solid fraction. However, one solid fraction in the numerator and one solid fraction in your denominator. However, those two fractions are not simplified. So we will not pursue, and we will not continue to move on until both fractions are simplified. All right. So what we need to do is to simplify both fractions. Now, by definition, simplified form, you cannot have common factors in your numerator and denominator. So what I mean is we need to look for common factors. I'm going to move over now to see my next, where I'm going on with this. Here I have a common factor in my numerator and denominator. Well, first I need to simplify, should I say, my numerator. My numerator here is 3x minus 6x. This is going to give me a negative 3x over 18 excuse me that there we go. And here I have 10x minus 35. I'm going to show you that I'm factoring out all in one step so I don't mess anything up. I just brought my denominator over. From here, I'm going to factor out 3. I need to reduce this by 3. Okay, well, I'm going to factor out here. Here's my next part. So what I'm going to do here is show you from a different arrow. I'm going to simplify by reducing negative 3 and 18, and I'm going to end up with negative x over 6. Here, I can factor out in my numerator 5, and 5 is also a factor in my denominator. So here I would have 5 out of my numerator, and I end up with 2x minus 7. All divided by, I'm going to factor out 5 out of 50. And I'm just going to go back to 5 times 10. Why am I doing this? Because I need to show you guys what factors I'm dividing out. In this case, 5. They're going to divide out evenly. And now I have a fraction in my numerator that is in its simplified form. And I have a fraction in my denominator that's also in its simplified form. So what I want to do now is I want to rewrite both my numerator and my denominator on this side of the paper so you guys can see where we're headed. So here I'm going to have negative x over 6 divided by 2x minus 7 all over 10. This is what we're left with once we simplified by dividing 5 by 5 in my denominator. What's next now is we're going to go ahead and simplify this. We're going to multiply. We're going to change this division into multiplication. We're going to use the keep, change method. All right. Again, this is a method that I mentioned in a previous video. I'm going to explain what I mean in just a second. In the keep, change method here, we're going to keep the first fraction, my numerator. I'm going to keep it exactly the same. So here I'm going to leave it as negative x over 6. I'm going to change my division into multiplication, just like elementary school, and I'm going to multiply by the reciprocal of my denominator, which in this case, it would be 10 over 2x minus 7. Now, from here, guys, what I'll be doing is going ahead and attempting to simplify by dividing out any common factors. Here, what I notice is that I have 6 and 10. Both of these are common factors. Now, I'm going to take a longer way just to show you guys every single thing that I'm doing. However, if you choose to do it a shorter way, by all means, as long as you understand, that's all that matters. Okay, so now what I want to do is write this here over here and show my factors, I'm going to factor out 2 out of 10, and I'm going to factor out 2 out of 6 to show common factors, the greatest common factor, that is. So here I have x times 2 times 5. This is my 10 here. 2 times 5, that's my 10. All right. And here for my 6, I'm going to have 2 times 3 times 2x minus 7. Now, do I need to do all of this? No, I don't. However, I'm doing this personally just to show you guys how I'm going from one step to the next and why I'm doing what I'm doing. Please understand the terminology that I'm using. All right, common factors. I'm showing you guys the common factors. In this case, it's 2. Some of you guys may say, okay, you could have just reduced this. That is correct. You will get the exact same answer. However, for the sake of the video, I'm showing out common factors. In this case, I can divide out my common factors. What's left with is my final answer. In this case, I'm left with 5x in my numerator. And in my denominator, I'm left with 3 times 2x minus 7. Guys, that's our final answer here. Again, I took extra steps by showing you guys in this step that I'm factoring out common factors. All right. I also did it over here in this step as well. I didn't have to do it like this. I could have just factored out 5 and then reduced 5 and 50. But I didn't. I chose to take an extra step to show you that I'm factoring out common factors. And I hope that you can appreciate this and understand what I mean when I say divide out common factors. This has been Mr. Holmes reviewing simplifying complex fractions. And if you know Mr. Holmes, you know what I'm going to say. I hope you enjoyed this video and have a blessed day.